The probable error of correlation coefficient. Either you are doing a correlation, okay, so we are finding the errors. Correlation symbols can be, you can write R, or you can write gamma, or you can write pi, okay, so which is directly given 0.8. There are two situations. One is non-repeated, the number is not repeated. So one more time the number is repeated, the rank is repeated 2 or 3 times. So in that case the different formulas we are using. Hello everyone, a warm welcome to one and all. I am Natesh, lecturer in Commerce, Vidhyaashram First Grade College, MYSURU, the Temple of Excellence. We are in the Unit 4, Session 4, 3rd semester Business Statistics BCom. So correlation and regression. And today my agenda is a probable error. What exactly the probable error, why it is connected to the correlation, okay. So there is in the last session which is related to Pearson, which is coming under the mathematical method. So here also we are trying to go for the next method, which is a Spearman rank correlation of coefficient. So which is the name only it is suggesting we are ranking, okay, we need to rank. So who is first, who is the best? Of course, we are doing a ranking using a Pearson, using a Spearman. In case of any ranking, the Pearson is not advisable. If you try to do for ranking, of course, we are depending on the Spearman. So now the agenda, as per today's agenda, the probable error means what exactly the probable error, what we are finding. The probable error is a measure used to find the extent of dependability, because we know the x and y are two variables. With the help of two variables we are trying to do for the correlation. So how what is the percentage it is a dependent, x is dependent on y is dependent on x. So the dependability nature we need to find out. So the dependability or reliability of the sample of correlation coefficient. So x variable, how the x is dependent on y is dependent on x. Of course, we need to find out the reliability. So the probable error of the correlation coefficient usually denoted by, in the symbolically when we are writing p dat e, so which is nothing but the probability p we are writing. So tell us the limit within which the various value of p means what exactly. So we are trying to do for the probable error using a two variables x and y, so which is completely the value basis only we are deciding of the various sample taken from the sample group of the entire group. Populations will be vary, because any probability which is completely depending on the population size, okay, the variability we are finding, we are checking the errors. It means that the different samples are drawn from the population, different sample, either large sample or small sample. There is a different types of discrete, under discrete method, under continuous series method. So in the last session I have explained which is related to continuous series, which is related to discrete series, okay. The error we are finding, even if the entire population is considered, the entire population, see, when you are trying to do for experiment or conducting a survey, we cannot select a entire population. That's what we are selecting, a random selection, or mu what we are saying, okay, selected population. Their correlations value will be between, okay, so plus or minus the probable error of the correlations coefficient, the probable error of correlation coefficient. Either you are doing a correlation, okay, so we are finding the errors. The probable error of the correlation coefficient is given by, there is standard formula, so which is the value always for 0.6745, okay, so 0.6745 into 1 minus r means what? The correlations what we are done. So using a Pearson, after calculating, you know the formula for correlations what we are finding. For example, n into sigma xy minus sigma x into sigma y divided by standard deviation for x series sigma x square, okay. and minus sigma x to the power of square and multiplied for y series also we are doing. So after whatever we are getting, we need to consider, we need to take the square. Okay, either it is a positive or negative what you did using a Colpearson or Spearman. Okay, so 1 minus r to the power of square divided by root n. Root n means the number of items. Okay, so here the uses of probable error, where exactly the probable errors we are using. So the probable error of the correlation coefficient may be used to determine the limits. Okay, because there is a standard limit we are setting. So that's what clearly specified in this previous 0.6745. So here the limit of the population correlation coefficient which the accepted lie. Okay, because you know we are using a graph like this. Okay, the exactly 0, so where exactly the critical limit we are identified. So using it. So in this case, which is a completely based on the probability distribution. Now the probable error we are trying to connect with the correlation. So that's what we need to go for the correlations expected lie. Therefore, the population correlation coefficient limit given by, which is given by P plus or minus P of B. So, which is the value is given in the here. Okay, the formula plus or minus. So, second one, this also implies that the even if we take another random sample or samples of the same size from the same population. Okay, so because we are selecting not one particular sample what we are selecting, first random, second random, so we are depending. So to check the errors, then the observation value of their correlation coefficient can be expected to lie within the limit of first sample. We are trying to compare with, for example, the total population assume 1000. We are selecting a first random 100, second random 100. So we are trying to check the errors what we are getting in the first sample and what we are getting errors in the second sample. So within the expected value which is lying. Okay, so we are just checking. So P of a plus or minus P of probability errors. So the third usage, the probability error always used to know the reliability or significance of the observed value, because in the observed value whatever it is given, so of this sample of correlation coefficient, because the probability error which is completely depending on the observation whatever it is given in the question or experimental basis. Now here there is one question which is related to probable error to understand. So the question, if the P, okay, directly the correlation, okay, the correlation can be, we can use like this, or you can write gamma, or we can write okay, so P type. So P is equal to plus or minus 0.1. Either you can pronounce pi. So plus or minus 0.8. N is equal to 64. What is the probable error? What are the limits of population correlation coefficient? So what and all it's given. So which is given, pi's value is given, n value is given. Okay, now we need to identify. So calculate P of E, the standard value which is given 0.6745 into 1 as it is we are writing, minus R plus we are writing 0.8. I told you the probability correlation symbols can be, you can write R, or you can write gamma, or you can write pi. Okay, so which is directly given 0.8. So now we need to take the square root divided by n plus, which is clearly specified in the question, 64. Okay, now first as it is I am writing. Okay, so first I want to take the square root. So 1 as it is minus sign 0.8 into 0.8 I am getting 0.64, 2 times if you multiply. Okay, divided by denominator I just want to remove the square root, I am getting 8. So again I want to simplify this one. So that's what I am writing, 0.6745 as it is. Okay, if you subtract, you're getting 0.36 from the 1 to 1 minus 0.64. If you subtract, you're getting 0.36 divided by 8. Again, I need to simplify this one as it is. I am writing. If you divide, you are getting 0.045. Okay, just multiply. You're getting approximations value also you can consider. Okay, 0.045. 0.030. So approximate 0.03. If it is 0.0356 means I can make it for 4 because round figure value. So here the limit for the population correlation coefficient which is clearly specified, so which is a plus or minus sign, correlation probable error which is approximately plus or minus, we are getting plus, so that's what we are writing plus. If I am getting minus, I just, here it is getting plus, so that's what I am writing like this. So the P1 minus whatever which is given in the 0.8, so from the P, pi or correlation, we need to subtract the errors. So if you subtract the error, because the question is asking what are the limits of population correlation coefficient. So what is given in the question, which is a correlation's value is given. So correlation minus 1 is plus, 1 is minus. First we are trying to do subtract. So we are writing as it is the correlation's value whatever it is given 0.80 minus the probable error we got a plus minus 0.03 because plus sign only I just want to write. So here the sign whatever it is there, here the plus, okay, minus into plus minus only. If you subtract you are getting the limit 0.77. And if you again try to go for the plus sign, because which is the limit is always plus or minus, okay, so P plus P dot E to the into P, so which is given 0.8, you have to do the errors add, if you add together you are getting, so the population pi will be lying between so in between 0.7 and 0.83 in between which is lying, okay. Okay, now as per today agenda which is coming under the mathematical method, so correlation using a rank correlation. So the Spearman is a person, okay, so he is introduced the rank correlation of coefficient, so which is 100% expected question, either the number is non-repeated or repeated basis. Here there is few examples problem. Sometime we come across ordinal data, sometime we come across ordinal data whatever it is given. So the variable under consider not applicable for quantitative measurement, because under quality we are not able to identify. So in the qualitative matter definitely who is best, who is better, so we need to using the Spearman only we can rank. So that's what the quantitative measurement, but can be arranged in rank. The quantitative data, otherwise you can call it as a quality. The quality is the best we are saying. So the rank in the serial order, we need to, for example, the 10 student who is top 1, okay, top 10 if you want to do. So 1, 2, 3, like this you are doing a ranking here. For example, who is the best singer? That's what I need to do for ranking using a Spearman. And who is a better actor? Who is a beautiful? In such a situation, Carl Pearson is not advisable. So that's what we are trying to do for Spearman. Okay, so Carl Pearson coefficient of correlation cannot be used because the ranking part it is very difficult. So that's what the Professor Charles Edward Spearman, the full name is Professor Charles Edward Spearman, a British psychologist, has developed a formula in the year of 1904, so which give the Spearman rank correlation coefficient. Okay, so instead of writing full name, so directly the Spearman rank correlation. There are two situations. One is non-repeated. The number is not repeated. So one more time the number is repeated. The rank is repeated 2 or 3 times. So in that case the different formulas we are using. Okay, the very simple. The formula for rank correlation, which formula whatever it is there in front of you, which is a number is not repeated. So in that case, P stand for correlation, pi stand for correlation, okay. So here we are using a Spearman, so directly we can write for yes, okay. So the Spearman coefficient 1 minus, okay, the standard formula 1 minus 6 sigma d square divided by n into n square minus 1, or you can apply this formula. Okay, so both are similar. What difference we are finding? Here we are finding square, here we are finding cube. So better it, which is applicable. I try to advise to depend on any specific one problem. So I'll try to suggest for this formula. So 1 minus 6 sigma d square in the numerator, whatever it is required, we need to find out. Okay, in the coming slides you will get more clarity. Divided by n cube, because the number is very important. Any question if you try to do, the number, how many numbers we are identify? N cube minus n. Okay, so this is very simple formula. Okay, so how to remember? So we are trying to go for always the probability assume 1. Okay, so from this we need to consider for 6 is a number sigma d square. Okay, so the total probability whatever it is coming, which is coming under the n cube minus n format, you must remember in this non-repeated data, the non-repeated numbers only we try to depend on. Now here we are writing correlation using Spearman. Okay, so is equal to, this is next one, where whatever we have written, Kp is the rank correlation. Okay, and d or small letter d, the difference we are finding. So that is a difference rank between the two series. Whenever you are trying to do for correlation, of course the two set of data is very important. So the difference we are finding, d stand for difference. So for your understanding, I am writing one more time, 1 is a total. Okay, 6 sigma d square divided by n cube minus n. Okay, so it's very simple formula. We are finding a Spearman correlation. Okay, or you can write Kp. Okay, so 1 is a standard, you must remember. It's very simple formula to remember. And either you are using a small letter or capital letter, no problem, but we are finding a difference. Okay, so n is nothing but the number of pair of observation. Okay, for example, X series and Y series, whatever it is there to do for the correlation. So we are trying to go for the pair. Okay, so just we are comparing. Okay, here the value of this coefficient also vary from any correlation which is related to +1 and -1 only in between. When Kp is +1, okay, that means positive. After calculating we are getting positive. After simplifying we are getting positive. There is a complete agreement in the order of rank correlation of the two series. When we are getting the complete agreement. So if Kp is getting negative, after simplifying we are getting negative, there is a complete disagreement. Okay, the disagreement. So between agreement means what we are agreed, which is a positive, but disagreement which is coming under the negative care. Okay, so between the rank of two series. In other cases, their high or low agreement or disagreement between the two series of rank depending on the value or direction. Because we know the correlation we are always using for finding the direction or finding the degree of correlation. If it is exactly we are getting 0 means there is no correlations between X and Y series. If you are getting 1 plus means it is a perfect positive correlation. If you are getting -1, which is a perfect negative correlation. So if you are getting 0.5, which is a high, if you are getting plus means, okay, you are considering for the high positive. Okay, if you are getting a negative means 0.5, which is coming under the negative correlation. Okay, so the value basis only we are deciding. That's what you need to refer for the session 1, the scatter diagram. So there you are getting a more clarity for comments. So now the computation of rank correlations, very expected question, of course very simple. So the following is a procedure of computing a Spearman rank correlation coefficient. So the first one, if if the rank given marks the rank of X, always consider R1. First X series we are consider rank 1, okay, and the rank of Y series we are mark as a R2, okay. Again X we are writing rank 1, for Y we are writing R1, because according to formula basis only we are trying to depend a number of steps. Second, once you completed, okay, then you are trying to go for, if R are not given, the rank which is not at all given in the question, you need to rank, okay, then assigning the rank of the data. So for example, here 5 data is given, okay, from X series 5 data is given, 8, 2, okay, or 12. Now you tell me, seeing the data we can decide the first rank we goes to last number, second rank 10, third rank 4, last rank 4th. This is what we are giving a rank, okay. So in some time in the question, if they are given rank directly, we can find for the D, okay. How we are finding D? So now from the X series we just did for the ranking R1. So again we need to do for Y also, again, which is very important to observe very carefully the question, okay. So the data, now then marks are for X series and R2 for Y series, okay. Now third step, compute rank difference, we denoted because the formula is there, 1 minus 6 sigma D square divided by n cube minus n, okay. In this case D is equal to R1 minus R2. This is a standard procedure, but after getting the D value, we are trying to do for D square. Directly we can multiply 2 times, okay. So the D, how we are getting R1 minus R2? Consider the symbol is very important. We need to consider minus and plus, otherwise the value will be differ, okay. We cannot ignore this sign. So now fourth step, square the rank difference, that is the D square. According to formula, whatever it is there, we are trying to do, okay. Obtain the total, which is nothing but you are getting a D square. So finally the formula, whatever it is there, we got. Now last one, substitute the figure into the formula, obtain pK value, or you can write pi Spearman rank correlation, okay. So there is one question, it is very clear. Two judge, okay, now the judge are they are trying to go for ranking. Two judge have rank 5, rank already rank 5 competitor in the beauty contest as below. They already rank, we just don't want to do any ranking, they already, the judge is given, the data is already rank, okay. So competitors A, B, C to E. The judge 1, the rank, the first rank is given for C, second rank is given for A, third rank is given for D, fourth rank is given for E, last rank is given by F. Now the judge 2 is given rank, the first rank is also given for C, second rank same, whatever the judge is given, the first judge, the same rank is given by judge 2. The question, okay, which is very transparent. Now we need to find out to D. D is simple formula, R1 minus R2. Again D square, using after finding this value we are getting D square. Very simple, the same what I have done already. The competitors and judge 1, judge 2, whatever the question is there, which is already ranked, okay. So I have written, now finding the rank difference, the simple formula R1 minus R2, which is giving a, because both the judge are given the same rank, that's what everything we are getting 0, okay. And after doing, we need to do for D square, how? D into D 2 times multiply, again we are getting 0, okay. Now we are trying to do for last step, which is apply the formula. The formula is simple, 1 minus 6 into sigma D square. Instead of this one, I try to depend on this always, okay, because it's very simple. 1 minus the number of items 1, 2, 3, 4, 5. Okay, number of item 1, 2, 3, 4, 5. Okay, now 6, 1 minus 1 place as it is I am writing. 6 place I am the 6 value whatever the formula is given I have written. Okay, d square we got 0 in the numerator completed. Denominator n number of item is 5 because the formula having a cube, so that's what 5 to the power of 3 minus 5 to the power of 3, so n plus again 5. So after doing n 5 to the power of 3, 125. 125 minus 5, if you subtract you are getting 120. So numerator 0 divided by 120, anything if you divide, anything you multiply, you are getting 0 only. Okay, so plus 1 minus 0, so we are getting perfect positive correlation. Perfectly positive correlation. So we need to comment. So that is very important. There exists a perfect positive correlation between the judge 1 and judge 2. Okay, this question is any rank is not at all repeated. So which is a non-repeated rank. So directly. There is one more question which is related to repeated. So here the treatment is something different. The treatment of tried or equal rank. For example, the first A, B, C, okay, the two candidates are getting a same rank. So in that case, we need to depend on the other formula. The Spearman formula is based on the assumption, that the rank are different. The rank are different, no problem. But difficult may arise in case of where two or more items are getting equal. Okay, for example, the first, second, even the first student he got 10 marks, the second student he got 20 marks, third student also got 20 marks. Again, I just want to rank same only. So in that case, that the procedures are simple, very difficult, very simple to understand. This happen while assigning a rank when two or more items are having a same magnitude. In such a case, practice is that their rank is put as average of their rank. Okay, why? Because in that case we need to equally assign. Okay, we cannot ignore. So we have to rank equally in between. How many ranks are assigned? Equally we need to distribute. Which the item would be got if they have a differed from the each other. Okay, so now if there are common or tied ranks, okay, both are getting same rank. So it is advisable to apply an adjustment or a correction factor. Okay, the correction factors which is having a different the equation for the formula. The adjustment is to add 1 by 12 into m to the power of cube minus m. M is a number of repetitions. Okay, so to d square. Finally the formula is always getting the difference. So that's what the same procedure what we did for non-repeated ranking. So in this case, where m is the number of times and items or values are repeated. Okay, for example, the first rank, second rank, third rank, till third rank there is no problem. And if you are getting a fourth rank, so there are two candidates are getting same marks. Okay, so in that case what we need to do, now already third is completed, now 4 and 5 in between we need to adjust, right? So that's what we are trying to depend on the correction factors. Okay, so here the formula is very simple. The Spearman we are using, so the formula is very simple. So once again, see, we need to assume a non-repeated nature. Non-repeated nature, in the non-repeated formula what we did, 6 into sigma d square divided by, now in this case we need to extend divided by 3 to the n to the power of n to the power of 3 minus n. Okay, so this is a normal case. So here two students are getting a 2 marks, same marks. Now two student place we are writing 2 times. That's it, the correction factors. Okay, so the two student, how we are differentiating, m1 is one student, m2 is one more student. Is it clear? If 3 student means M1, M2, M3. The correction factor we just want to extend. Okay, in case of 2 student, I am just writing. So here the plus sign, okay, we are adding, right? So that's what. So the correction factor you must always remember 1 by 12 into M1 is the first student to the power of 3, because the formula is always having a cube. So 3 minus M, okay, the first student. Again, you need to extend for second student. So here M1 place we are writing M2, okay, M1 place we are writing M2. So till which is the extending. Very simple, the repetition. So whatever you are using for the non-repeated formula, with the repetition we are extending using a correction factor. The correction factor you must remember. So 1 by 12, okay, into M, first student M, okay, small letter M, to the power of 3. Again minus M, okay, the first student. Now in case of second student, the same marks is assigned. So same thing, 1 by 12. So M2 to the power of 3 minus M. In case of third student, so which is still extending the number of student, how many times the same marks are obtained. Okay, so here pi s is equal to rank correlation. Which rank correlation? Spearman. D stand for difference, which is a rank 1 and rank 2. And M1 is a number of times the value are repeated first time. M2 is a number of times second value are repeated, and so on. So if in case of 3, M3, so N is equal to number of pair observation, From the X series and from Y series also we can expect there is the same numbers are repeated. In case of X series also, in case of Y series also. Assume in X series there are 2 times are repeated the same number. Assume in the Y series there is no repetition. Then also we are try to do for the repetitions. Okay, the tide. So there is one questions to understand the treatment of tide and equal rank. So the question, the numbers from the marks of statistic we consider X variable, X, and marks of max we consider for Y. So here from first series we need to identify any numbers are repeated. 10 is not repeated in the 4 is not repeated, 2 is not repeated, 5 is repeated, 2 times is repeated. Now consider which is M1. Okay, so 6 is not repeated, 8, 9 is not repeated, 8 is not repeated. So from the max Y series, 10 is not repeated, 6 is not repeated, 2 is repeated 2 times, 5 is repeated 2 times. Okay, so here also we are finding a repetition. Okay, in case of the 5 is 2 times is repeated, 2 is 2 times is repeated, 9 is not repeated, 8 is not repeated. Whatever it is given horizontal, have written vertical format. Okay, now we need to rank for X series and Y series. From the X series first ranker, we are assigning for 10, highest value 10. So next 10, below 10, next value is 9, second rank, third rank 8. Okay, after 8, 7, it's not there. Now 6, fourth rank. Now fourth rank, after 6, 5 is 2 times is coming. So we need to, now fourth rank we already assign. So 2 numbers, 5 is 2 times, no. So 2 numbers, which is ending rank for 6. Ending rank is 6. So now I need to assign 5 and 6 because the 5 is 2 times are repeated. So equally if you rank means 5.5, 5.5. Okay, both of them we are getting 5.5, 5.5. Now 6th rank is also completed. Now 7th rank, after 4, after 5, 4, 7th rank. After 4, next value 2, 8th rank. There are 8 numbers, 8th rank is already assigned. Now moving to Y series. The first rank we are assigning for 10, highest value, highest mark is 10. Second rank is 9. Third rank is 8, 3. Now 3, after 8 there is no 7. Now I just want to assign for the 4th rank. So after 8 there is no 7, 6, 4th rank is completed. After 6, next 5 is 2 times coming, right? So 2 times. So now already 4th rank is completed. Now 5 is 2 times, means we need to assign 2 more rank. So which is ending for rank is 6. Ending rank is 6. 5. 4 is already assigned. Now 4th rank is completed. 2 more rank we need to assign. 5, 2 times is there. So 2 more. The ending rank will be 6. Now equally the 6, I just want to assign 5 and 6. So 5 is 2 times. So that's what equally I want to rank. So that's what I am writing, 5.5 and 5.5. Now 6th rank also completed. Now moving to 7th rank. Now after 5 there is no 4, okay, after 4 there is no 3 is not there. Now 2 is 2 times or repeated. 2 is 2 times or repeated. Now 6th rank already completed. Now 6th rank is completed. 2 more rank I want to add, so which is ending rank is 8. Okay, now the 6 we are equally, we need to, now 7th rank is left and 8th rank is left. So equally we are assigning 7.5. So that's what we assigned, 7.5, 7.5, 2. Okay, after 2 there is no 8 item is completed. So moving to D. To find out the D, R1 minus R2. Okay, so R1 minus R1 1, R2 1, 0, 7 minus 4, 3, 8 minus 7.5, 0.25, 5.5 minus 0.5, 0, 5.5 minus 7.5, minus 2, 4 minus 5.5, minus 1.5, 2 minus 2, 0, 3 minus 3, 0. Okay, now immediately we are trying to do for D square. 0 into 0, 0, 3 into 3, 9, 0.25 into 0.25, 0.25, 0 to the power 0, 2 minus 2, minus 2, minus into minus 2, minus 2 into minus 2, 4, minus 1.5 into minus 1.5, 2.25, 0 to the power of 0, 0 to the power of, if you take summation, sigma D square is 16.25. Whatever the formula is in, there we got the value 16.25. So moving for the formula, so we are using a Spearman rank correlation. The formula is already, it is clearly specified, 1 minus 6 sigma D square plus the first rank, okay, 5 is repeated and 2 is repeated. Okay, so in that case same thing, divided by n to the power of 3 minus n. Okay, so here m1 and m2 is 2 times or repeated, so 2 and 5 is repeated. So denote the number of times rank or tied in the both variable, okay, x and y, or statistical mathematics. The subscripts denote the first tie and second tie. So in the both the variable, so as it is 1 I am writing 6, as it is I am writing sigma D square, we got 16.25. The first rank correction factors I have written, so 2 to the power of 3 minus 2, okay. So same thing, the 5 is 2 times is repeated, so 2 to the power of 3 minus 2 divided by 2, the correction factor, denominator n plus number of item is given 8, 8 to the power of 3, so minus 8, so we need to subtract. So as it is the one I am written as it is, okay. So here I just want to write, now I want to simplify this one first. So here 16.25 as it is I am writing. So this one how much you are getting? 2 to the power of 3 means 8, 8 minus 2, 6, 6 divided by 2. See once again, 2 to the power of 3 means 8, okay, 2 3 times multiplied 8, 8 minus 2, 6, 6 into 1, 6, okay, numerator 6 divided by denominator 6. Again the correction factor for next repetition, same, 2 to the power of 3, 8, 8 minus 2, 6, 6 into 1, 6 into 1, 6 divided by 2. So now what we need to do? We need to simplify this one first. So as it is I am written 1 minus 6 as it is I am writing, 16.25 as it is I am writing. So I just want to divide this one, 6 divided by 12 we are getting 0.25, and again plus sign, 6 divided by 2.12 we are getting 0.5. We simplify denominator 8 3 times multiply 8 into 8 into 8. So minus 8 if you do 504 we are getting. So again we need to simplify this one. So what we are doing, we have to take the summation. So 1 minus 6 as it is. If you take the summation, we are getting 17.25 divided by denominator as it is. So first I just want to numerator multiplication 1 as it is, minus sign as it is. If you multiply, you are getting 103.5 divided by 505. So again I just want to simplify this one. So that's what I have written, plus 1 minus, if you simplify, you are getting 0.205. Okay, from this if you subtract, you are getting 0.795. Seeing this value, we are identify which is a high degree of positive correlation. Okay, so there exists a high degree of positive correlation because which is more than 0.5. So that's what we are writing, high degree of positive correlation between x and y, or you can write high degree of positive correlation between marks in statistical and marks in maths. Keep on watch for next section. Thank you.